Okay, welcome back to math class and welcome to part 2 of 9-3 transformations of quadratic functions. Okay, yesterday we talked about basically how to translate our quadratic functions side to side or up and down. Today we're going to talk about dilations and reflections. Now, a dilation is when we multiply a dilation of any shape. We've done this already, you should remember. It's scaling it up or scaling it down. So in this case with parabolas, what we're doing is making our graph wider or narrower. So if I had just my normal x squared, right here, it's gonna look like this. But if I multiply, if I have an a out here to the front of x, to the front of my x squared, so if I had 2x squared, what that's going to do to my graph is it's actually going to make it narrower. So whereas this one is this wide, this one is going to look more like this. Now that's if I'm multiplying by something that is by an a that is greater than 1. If a is greater than 1, this number out to the side of x squared is greater than 1. It's making up my graph narrower. If my dilation factor is less than 1 but still greater than 0, still positive, in other words, a is less than 1, greater than 0, still positive but it's a fraction, then it's going to make my graph wider. It's going to make my parabola wider. So we have normal. When a is greater than 1, we have a narrower parabola. When a is a fraction, we have a wider parabola. Now I know what you're thinking. What happens when a is negative? And that's where the reflection comes in. A reflection occurs when our a value changes signs. It's going to reflect it over the x-axis. So here's my x squared. If instead of x squared I had negative x squared, what I'm saying there is I'm taking my graph just how it normally was, and I'm reflecting it down. It doesn't matter what the a is, it's just the reflection of it down. So negative 2 x squared would be the same as this one, just in the opposite direction. Same with this, negative 1/2 x squared would be the same as this one, really wide, just in the other direction. So it's a dilation. We're getting narrower or wider, and a reflection is flipping it in the opposite direction. All right, one last thing before we move on to your homework, and that is, so we've learned all of these pieces, how to move it side to side, up and down, make it wider, skinnier, and whether we need to flip its direction. The way that we write all of this to describe this process is called vertex form. Vertex form. Now what that looks like is a times x minus h squared plus k. Now you should remember from yesterday and what I just told you today, our A is going to tell us both how wide our graph should be and whether A is positive or negative is going to tell us whether our graph is upside down or not. Whether it's coming down or whether it's coming up. All right, that's our A value. Our H is going to tell us how much it moves side to side. And our K is going to tell us how much it moves up and down. Okay, so if you were given something in vertex form, with all of these pieces filled in, you should be able to plot it on a graph relatively simply by knowing each of these pieces. I need to, where should I put my vertex? I need to move it how far up and down, how far side to side, is it going to be upwards or downwards, and how wide should I make it? One of the main things that we're going to be doing on this homework assignment is I'm going to put a graph, there'll be a graph there for you, and it's going to have multiple choices of what the equation of that graph will be, and you're going to have to figure it out. And one of the ways that you can do that is by looking for all of these things. For example, if my K was positive 2, then I would know that the graph has to start at least up here. But if my H was minus 4, then I would know that I have to start positive 2 up here, but side to side I need to come over 4 spaces. And if my A was 3, then I would know that it's not going to be upside down, it's going to go up this way, and since A is greater than 1, it's going to be a really narrow parabola. This is just an estimate, but you should be able to look at a parabola like this and count, oh, I counted 4 spaces this way, so now I know my H is minus 4. Oh, I counted 2 spaces up, so that means my K is going to be positive 2. Things like that. You should be able to look at this and tell. And that's all we're doing with this lesson today.